All right, continuing on to question number 12. Sorry about that, I got interrupted. Um, yeah, 3y cubed divided by x to the 6 is equals to 2 to the x power. And again, the derivative of 2 to the x power is pretty straightforward. The derivative of 2 to the x power is just 2. The other derivative requires a little bit of work. And so you have your 3y cubed and you have your x to the 6th. The derivative is 9y squared y prime. The derivative is 6x to the 5th power. And so again, you multiply these two together followed by these two. But this time you have a minus sign and then you have to divide by the denominator squared. And so that's going to be 9y squared y prime multiplied by x to the 6th plus 3y cubed multiplied by 6x to the 5th. And of course that's equal to 2. But instead of being a plus, it is now a minus. And I have to divide by the denominator squared. And so that is 9x to the 6 y squared y prime. I got to get to that y prime. Minus 3 times 6 is 18x to the 5th y cubed is equals to 2, and that's divided by x to the 12th power. I cancel that x to the 12th by multiplying both sides by x to the 12th. And of course, these will cancel. So that's 9x to the 6 y squared y prime minus 18x to the 5th y cubed is equals to 2x to the 12th power. And now I got to unwind to get to the y prime. So I take the numbers over. 9x 6y squared y prime is equals to x to the 12th plus 18x to the 5y cubed. And then I divide by everything except y prime. Of course, these will cancel. And so therefore that is my y prime. But as with every fraction, I need to simplify as much as possible. If I look very carefully, I will notice that every term has x's in there, and so I can cancel out some x's. If every term was even, for example, I could divide by 2. If every term had an x, I can cancel out x's, and so forth and so on. The lowest power of x is 5, and so I'm going to subtract 5 from each term. This cancels all the way out. This becomes a 1, and 12 minus 5 is 7. And so then that leaves me with my answer of 2x to the 7th plus 18y cubed divided by 9xy squared. And there is my y prime, my derivative using implicit differentiation. Alright, we move on to finding the second derivative. For the most part, these are pretty straightforward. You just gotta take the derivative twice. But of course, sometimes you have to rearrange the problem to make it the derivative possible. Number 13, I have f of x is equals to 6x plus 3 multiplied by 2x cubed minus 4x. I FOIL this thing out first and then I take the derivatives. So that is 12x to the 4 minus 24x squared plus 6x cubed minus 12x. The first derivative, f prime, 48x cubed minus 48 x plus 18x squared minus 12. And then the second derivative, 48 times 3, 144x squared. Make that for loop properly. 144x squared plus 36x, the derivative of this, minus 48. And that's your second derivative f double prime. That's your answer right there. Number 14. Okay, remember, you can always go back and pause and rewind and try different examples as you go along. 6 ln x, the first derivative is one that comes from memory. That is 6 divided by x. The 6 goes to the numerator, the x goes to the denominator. But before I can take the second derivative, I have to rearrange the problem. This is 6x to the negative 1. And now I can take the derivative, negative 6x to the negative 2. And so my final answer is negative 6 divided by x squared. So after I took the first derivative, I then had to rewrite the problem, and then I could go ahead and take my derivative. For number 15, I have f of x is 10 times the cube root of x to the 8th power. But this one, I actually have to rearrange it first. So f of x is 10, and then I have x raised to the 8/3 power. And now I multiply. 8 times 10 is 80. 10 over 1, so that's 80 over 3. X to the 5/3 power. 8 minus 3. 8 over 3 minus 1 is 5/3. And that's my first derivative. And I'm just going to press on to the second derivative since that's what I need. 5 times 8 is 400 over 9. X to the 2/3. And so therefore this is 400 over 9, the cube root of x squared. And that is your second derivative. Notice that I didn't simplify the first derivative because I'm looking for the second derivative. And so there's no need to go through that step. So you just gotta keep that in mind. No, it saves you a few seconds. Not that much. Number 16, f of x is equals to 3 over x cubed, which is 3 over x to the negative 3. And now I am ready to take the derivative. Uh-oh. Not writing. I have to reset. Ooh, that's huge. Come on. Right, and so f of x right here. And so your first derivative is negative 9x to the negative 4. What's your signs? Negative 3 minus 1 is negative 4. And again, f double prime is 9 times 4 is 36x to the negative 5. And so your final answer is 36 divided by x to the 5th power. The 5th power, I say. Number 17. Again, question I have to simplify first before I can take the derivative. X to the 4 minus 6x squared plus 2x divided by x to the squared. That is equals to x to the 4 minus 6x squared plus 2x. Notice here I'm multiplying by x to the negative 2. Okay, you gotta be careful here. If you're not adding x to the negative 2, you're multiplying x to the negative 2. And so I distribute it. These two first terms multiply to give me x squared. The x's cancel, so that's negative 6. And then the last one, when I multiply that, I get plus 2x to the negative 1. Now, I am ready to take my derivatives. F prime is 2x, derivative of 6 is 0, minus 2x to the negative 2. derivative of this right here. And then f double prime is 2 plus 4x to the negative 3. So my answer is 2 plus 4 over x cubed. There you go. Oh, number 18 looks like fun. Oh, number 19 looks crazy. F of x is equals to 2e to the x. F prime 2e to the x. F double prime 2e to the x. F triple prime 2e to the x. F to the fourth derivative of x is 2e to the x, and so forth and so on. F the 100th derivative, it will still be 2e to the x. On the other hand, number 19, we're going to need a lot more space to find the second derivative for number 19. I have a function, f of x is equals to 2e to the 3x squared minus 6x plus 2. The first derivative requires that I find the inside 3ex squared minus 6. Why am I using e? 3x squared minus 6x plus 2. And then the outside function, which is 2e to the x. The derivative of the outside, because again, this is a chain rule, so I'm building this answer slowly, is 2e to the x. I then have to plug the inside function back in, 2e to the 3x squared minus 6x plus 2, and then multiply by the derivative of the inside function, which is, what's 3 times 2? 6x minus 6. The thing is, to find the derivative of the second derivative of this function, f double prime, I have to recognize that this is a product. This is this right here multiplied by this. And if that's the case, I am going to need a graphic organizer to find the second derivative. My first function is 2e 3x squared minus 6x plus 2. And my second function is 6x minus 6. Notice how this function just changed. Notice how this function just changed from a very simple chain rule into, oh my goodness, I gotta do a product rule. To take the derivative of this function, I have to use the chain rule again. Yes? But the nice thing is that I already have found the derivative of this, because this is exactly the same as this. So I know the answer is going to be 2e to the 3x squared minus 6x plus 2 multiplied by 6x minus 6. The derivative of this is simply 6. And so this thing is going to be 2e to the 3x squared minus 6x plus 2 multiplied by 6x minus 6 multiplied by 6x minus 6 plus, and I gotta multiply these together, and that's going to be 12e to the 3x squared minus 6x plus 2. So this is going to be equals to 2. When I multiply these two things together, I get 6x minus 6 squared, e to the 3x squared minus 6x plus 2 plus 12e to the 3x squared minus 6x plus 2. And that's the answer right here. What else can I add right here? You can factor out 2e to the 3x squared minus 6x plus 2, but that's up to you. This right here is our answer.